In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make the channel a grand success. We are a family, a partner. Please subscribe and share our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much for your precious time. Okay, today I'm going to discuss oil and gas productions, exploration, production, upstream, midstream, refining, petrochemicals, differentiated performance and profit optimizations, lecture number 18. Okay, before my lecture, I used to read a Quranic verse. Qala Rabbi shrah li sadri wa yassir li amri wa halal uqdatam min lisani yafqahu qawli Allahumma Rabbi zidni ilma. O my Lord, open my chest and ease my task for me, and loose not from my tongue that they may understand my saying. Allahumma Rabbi zidni ilma, O Allah, advance me in my knowledge and true understanding. Okay, please send me your feedback, comments. I have provided my WhatsApp number and email address end of my presentation. Okay, oil and gas productions. So the introductions, facilities of process, reservoir and wellhead, upstream facilities, midstream facilities, refining facilities, petrochemicals, utility systems, conventional and unconventional resources and environment effects. What is the ultimate goal? Shaping the clean and sustainable global energy. We have a plan to deliver a more than a 300 lecture in the next couple of years. Okay, oil and gas production midstream facilities, lecture number 18. Today we are going to discuss gas processing, acid gas removal, and its different process segments. Okay. Okay, key takeaway points, lecture number 18. Facilities process, onshore offshore facilities, gas processing, acid gas removal, absorption, cryogenic and sulfur unit. Today we are going to discuss in detail. Okay, gas processing. Raw natural gas must be processed to meet the trading specification of the pipeline and a gas distribution components. As part of the purifications, other components such as NGL is produced and pollutants extracted. If you can see here, the diagram shows our marketable products are listed in the blue and the product process is shown in the gray color. It's not considered as a part of the gas plant. Okay, so the blue color here, these are the marketable products. So these are the marketable products. From my next slide, we will discuss acid gas removal, dehydrations, mercury removals, nitrogen re-injections, and NGL recover segment by segment. Okay, from next slide, we'll discuss acid gas removal. Okay, now we're going to discuss acid gas removal. Acid gas such as carbon dioxide and hydrogen sulfide form acids when reacting with water content and must be removed to prevent corrosive damage to equipment and pipeline. Hydrogen sulfide is also toxic and total sulfur content is normally regulated. Okay, if you can see here, this is my absorption tower and this is my regeneration tower. So process stream already explained. Absorption tower. Absorption allows acetic gas to be dissolved in a solvent or to be released by the regeneration in a later stage. Amine absorption is the most common process for acid gas removal. Monoethanol amine dominates of our CO2 removal. Okay, a typical amine gas treating process consists of an absorber unit, a regeneration unit, and accessory equipment in the absorption. A lean amine solution absorb H2S and CO2 from the upflowing sour gas to produce sweetened gas stream as a product. If you can see on the top here, this is my sweet gas. Okay. The rich amine solution contains the absorbed acid gas and is routed into the regeneration section, the steeper with reboiler. The steeper overhead gas from the regenerated consists of H2S and CO2. This is the steeper here, regeneration tower, steeper, and this is the acid gas contain H2S and CO2. Okay, from the next slide, we will discuss each process as we have explained in my earlier slide. Okay, absorption. So absorption consists of solvent, dominant, rich amine, a lean amine. So absorption allows acetic gas to be dissolved in a solvent or to be released by regeneration. In a later stage, amine absorptions is the most common process for acid gas removal. Monoethanol amine dominates for CO2 removal. Okay. Okay, adsorptions. Molecules PSA, ESA, and sulfurs. Okay. PSA are pressure swing adsorptions, and ESA electric swing adsorptions. What basically demonstrate here? Adsorptions relies on the molecules to bind to the surface of certain solids. After a certain time, the material must be regenerated to release the gas. Principally used including pressure swing adsorptions, temperature swing adsorption, that is TSA, and electric swing adsorption, that is ESA. Okay, from the next slide, we will discuss a cryogenic. What is a cryogenic? Okay, cryogenic process. Turbo expanders cools to below the dew point for the gas removal, dew point, and carbon dioxide. Cryogenic removal uses a turbo expander. A gas turbine is driven by expanding gas which then cools to below the dew point for the gas to be removed. The inlet gas to the compressor is pre-cooled by the acid gas removal. Cryogenic removal is most often used when the content of carbon dioxide is high, typical around 50%. Okay, so from next slide we'll discuss membrane system. Okay, membrane system consists of materials, acid gas, or combinations, both of them. Membrane-based removal is based on certain material that allows the acid gas but not the hydrocarbons to diffuse through the membrane. This procedure can be performed alone or in the combination with absorption liquid. Okay, sulfation comprised of multi-stage process, thermal section, and catalytic section. Sulfur unit, the rich H2S steeped gas stream is then fed to the closed process of multi-stage process with two main sections. One is a thermal section, fires hydrogen sulfide with air or oxygen to produce SO2, sulfur dioxide, and elemental sulfur, which is released when cooled. A catalytic section allows a more hydrogen sulfide H2S to react with SO2 with alumina or titanium dioxides to produce water and elemental sulfur. The closed process can recover 95 to 97% of sulfur in the feed stream. Okay. Okay, tail gas treatment. This is my last slide, and then we'll conclude today's presentation. Tail gas treatment. Unit serves to reduce sulfur content to below 250 ppm, corresponding to a total sulfur recovery of 99.9%. More complex solutions can reduce a total sulfur down to 10 ppm. Some important processes including SCOT, SCO2, shell close off gas treatment, which removes SO2 sulfur dioxides by combustions with hydrogens over catalyst to produce H2S and water. H2S recycled to the closed units. Other solutions are also applied, that is beyond a sulfur removal, BSR, based on amine and solvent and catalyst. Thank you very much for your precious time. Okay. Conclusion, today we discussed gas processing, acid gas removal, absorption, adsorption. Okay, our next plan, we will discuss dehydration, mercury removal, nitrogen reinjections, and angel recovery and treatment. These are few references. Qatar Petroleum, Oil and Gas Development, World Energy Outlook, US Geological Survey, US Department of Energy, Schlumberger, International Energy, Wikipedia, Oklahoma State, Marginal Well Commission, Pumpers, State Oil Fact Sheet, NORSEX Standard, The Story of Oil in Pennsylvania, A Liquid Gas Encyclopedia, Natural Gas from Wellhead to Burner Tip. Okay. So together everyone achieve more. Please do not hesitate. Send me your feedback, comments at t.masood.dear@path.edu. I have also provided my WhatsApp number. Please, you may send me WhatsApp. Thank you very much for your precious time. Please stay at home, stay safe, inspired, and blessed. Thank you.